Welcome to Mathematics Lecture Series, Laplace Transform, lecture number 2. So, we have discussed in last lecture these two formula Laplace of t power n, gamma n plus 1 over s power n plus 1 when n is any real number. You know that gamma 1 by 2 is equal to under root pi. Laplace t power n is equal to n factorial over s power n plus 1 whenever n is a natural number. So by using these formulas we find the Laplace transform of t square root t. So Laplace of t square by using the formula Laplace of t power n factorial over s power n plus 1. Here n is replaced with 2, so 2 factorial over s n plus 1 means s power 3. This is the answer of Laplace of t square. Now Laplace of square root t, so t power 1 by 2. So t power 1 by 2 we use the formula gamma n plus 1 over s power n plus 1. Here n is equal to 1 by 2. So gamma 1 by 2 plus 1 s power 1 by 2 plus 1. This is gamma 3 by 2 and we adopt the recurrence relation. So it becomes 1 by 2 gamma 1 by 2. So gamma 1 by 2 is equal to square root pi. So square root pi over 2s 3 by 2 is our answer of this Laplace of square root t. Now Laplace of e power at. By definition, Laplace of e power at. By definition of Laplace transform 0 to infinity e power minus st. Here f of t is e power at dt. So e base are same, so power must be added e minus st plus at dt. E take the common between these two, which is t, so we have minus t, take the common, so s minus a is other dt. So integration of this term is e power minus t s minus a over s minus a. Integration with respect to t is equal to e power minus t s minus a over minus s minus a. Upper limit, lower limit. Apply the upper limit, so upper limit e power minus infinity minus 1 over s minus a. We write the outside minus apply the lower limit, so e power 0. E power minus infinity, you know that it is 0. So e power 0 is equal to 1. So minus into minus plus, so we have 1 over s minus a. Here is by mistake it is plus. So Laplace of e power at is equal to 1 over s minus a. S must be greater than a. Here by using this you can say that Laplace of e power minus at is equal to 1 over s plus a. So these are itself these are themselves are formulas. So in next you can use these formulas. Now find Laplace transform t power minus 1 by 2. Laplace t power minus 1 by 2 is equal to gamma minus 1 by 2 plus 1 over s power minus 1 by 2 plus 1. By formula Laplace of Tn is equal to gamma n plus 1 over s power n plus 1. So minus 1 by 2 plus 1 is equal to 1 by 2. So gamma 1 by 2 is equal to square root pi. So square root pi over s is our last answer of Laplace transform of t power minus 1 by 2. Now find the Laplace of e power 3t by using the formula Laplace of e power at is equal to 1 over s minus s. So Laplace of e power 3t is equal to 1 over s minus 3. Now find the Laplace transform of the sin at and cosine at. So before to find this Laplace sin at, we must memorize this formula. Integral of e power a sin bx is equal to e power ax a square plus b squares a sin bx minus b cosine bx. E power a cosine bx is equal to e power x a square plus b square a cosine bx plus b sin bx. Now find the Laplace of sin at. Laplace of sin at is equal to integral by using the definition of Laplace transform. Integral 0 to infinity e power minus st is the kernel of Laplace transform and the function sin at dt. Now we have to solve this integral by using this formula. So here e power minus st a square, a is equal to s here and b is equal to a, so s square plus a square. A is equal to s, so s minus s sin at minus b is equal to, so a cosine bt, so means cosine at. Now apply the upper limit and lower limit. So take the common, write the outside 1 over s square plus a square. So use the upper limit e power s infinity. So e power minus s infinity is e power minus infinity and it is equal to 0. So could we not write the we, we could not write the other terms. It goes to 0. Here e power 0, so a minus a sin 80, sin 0 is equal to 0, so this one becomes 0. Minus a cosine 80 means cosine a 0, cosine 0 is equal to 1, so we have just minus a. E power 0 is 1, this term goes to 0, just we have the a. So a over s square plus a square. So Laplace of sin 80 is equal to a over s square plus a square. Now Laplace of cosine 80. Similarly, Laplace of cosine by the definition of Laplace transform 0 to infinity e power minus st cosine 80 dt. Here it is equal to 1 over s square plus a square. 1 over s square plus a square e power minus st minus s cosine 80 plus a sin 80 infinity over 0. So by the previous slide formula we have this one answer of this integral. Now 1 over s square plus, use the upper limit e power minus and it is 0. So plus lower limit and lower limit e power 0 s minus 0, so just we have the s over s square plus a square. Here sin 0 is equal to 0, cosine 0 is equal to 1 and e power minus infinity is equal to 0. So Laplace of cosine 80 is equal to s over s square plus a square. So it is itself a formula, so in next we can use this formula. Now find the Laplace of sin 3t cosine 3t. Sin 8t, Laplace of sin 80 a square s square plus a square. By using this formula you have the Laplace of sin 3t. Here a replaced with 3, so 3 over s square plus 9. Laplace of cosine 80 is equal to s over s square plus a square. By adopt this formula you have the Laplace of cosine 4t, which is equal to s over s square plus 16. Now find the Laplace of sine hyperbolic 80. Find the Laplace of sine hyperbolic 80. Sine hyperbolic 80 is equal to e power 80 minus e power minus 80 upon 2. Therefore, Laplace of sine hyperbolic 80 is equal to 1 by 2 Laplace of e power 80 minus e power minus 80. Apply this operator Laplace of e power 80 minus Laplace of e power minus Laplace of e power 80 is equal to 1 over s minus, and Laplace of e power minus 80 is equal to 1 over s plus a. By taking LCM you will have s plus a minus s minus a, s minus s plus LCM. So plus s minus s will be cancelled, plus a 2a and 2 will cancel with this, s minus s plus a is equal to s square minus a square. By using formula a plus b a minus b, it is equal to a square minus b square. So Laplace of sine hyperbolic at is equal to a over s square minus a square. So it is itself a formula. And next in our problems we will use this formula. Similarly, you can easily find Laplace of cosine hyperbolic at. Cosine hyperbolic at is equal to e power at e minus at upon 2. So Laplace, apply the Laplace, so Laplace of e power at, Laplace of e power at 1 over s minus a, Laplace of e power minus at 1 over s plus, taking the LCM s minus s plus a. So here we have s plus a, this LCM divide with this s plus, so you will have s minus a will cancel, so you will have s over s square minus a. So Laplace of cosine hyperbolic at is equal to s over s square minus a square. Now find the Laplace of sine hyperbolic 3t and cosine hyperbolic 4t. So Laplace of sine at is equal to a over s square minus a square. By using this formula, Laplace of sine hyperbolic 3t is equal to 3 over s square minus 9. Laplace of cosine hyperbolic 8s square. By using this formula, cosine hyperbolic 4, the Laplace of cosine of 40 s over s square minus 16. This is a formula list which we have solved. Laplace of 1 is equal to 1 over s, Laplace of t is equal to 1 over s square, Laplace of t power n, if n is natural number, n factorial over s, n plus 1, Laplace of t power n, which is equal to gamma n plus 1 over s, and when n is a real number. Laplace of e power at, we have proved 1 over s minus a, Laplace of e power minus at 1 over s plus a sin at Laplace a over s square plus cosine at s over s square plus a square sin hyperbolic at Laplace is equal to a over s square minus a square cosine hyperbolic t Laplace s over s square minus a square. So this formula must you have in your mind. For further we will use these formulas in next problems.